So here's our next example with a vertical shift. Notice here I've put the value in front instead of in the back, so we want to make sure and handle both of those. Remember, this is the same thing. This is the same thing as if the negative stays with the value behind it. This is the same thing as if I had written negative cosine of x plus 2. These are the same thing, but you should get used to seeing these in both forms. So I will freely flip between the two, and you should get used to doing those. So remember, if there's no sign, we assume this is positive. So this is actually an adding 2. You might think this is you're subtracting 2. No, 2 is positive. 2 is getting added. And so we take care of this by writing, so we do the basic shape. The basic shape is the negative cosine graph. Right, that's the upside down cosine graph. The amplitude. The amplitude is the coefficient, the coefficient in front of cosine, absolute value of that, absolute value. And so this is absolute value of -1. This is -1 times cosine. All right. And then there is a vertical shift. There is a vertical shift. The vertical shift, since this is actually a positive 2, the negative is with the cosine, the positive is with the 2. The vertical shift is actually up 2. Let me separate that a little bit. Now, what if this were -2 minus cosine of x? Basic shape would still be negative cosine. Amplitude is still -2. But here, the vertical shift would be -2. This negative goes with the 2. This negative goes with the cosine. The negative goes with the value behind it. The negative stays with the value behind it. The negative goes with the value behind it. All right, so we got to shift up 2, amplitude -1, absolute value of -1, and basic shift is basic shape is the negative cosine. So I'm going to draw my graph here. I have to shift up 2, so I'm going to sort of plan ahead. Again, do the shift first. When you draw this graph, do the shift first. The axis is no longer the x-axis. Shift up 2. This is now the axis, the central axis of the graph. From here, from this point, not from the x-axis, from here is where you count the amplitude. The amplitude is 1 up and 1 down. It's absolute -1. The amplitude is actually 1. So this is 3 and this is 1. So the peak line is at 3. The trough line is at 1. So do you see the rule? Shift first, the axis. From the axis, you count the amplitude. So it's actually, you're doing this from bottom to top. Vertical shift, shift first, then count up and down the amplitude to get the peak line and the trough line. And then now we can put our horizontal axis in position here. This is now 3. So this is about 3, which means that's about pi. If that distance is pi, that distance is about 2 pi. Again, this is just approximating, but it's close enough. Here's pi over 2. Here's 3 pi over 2. And there are the sidelines. So this is the field of play, if you will. Field of play, rather like the Kansas City Chiefs have a field of play. And now put in the 5. So we actually do this in reverse sequence. Vertical shift to find the axis, amplitude to find the peaks and the troughs, and then the basic shape to find the 5 basic points. Trough, node, peak, node, trough, play connect the dots. Thanks for coming out. Make big dots. If the line misses the dot, just make the dot bigger. And that's good enough for us. That's okay. Don't worry about the little details. It's fine. This is good enough to get the basic idea across, which is what you will need going forward in certain types of applications. All right? So let's see if we can play another here. Let's play one more like this. Let's go f of x equals, let's go 6. Let's go 6 minus. Let's go -6 minus sine of x. Negative 6 minus sine of x. In fact, why don't we do this? Why don't you pause the video and see if you can work through this on your own and see if you can find what the graph looks like, and then afterwards I'll see if I can get the correct, see if mine can be as correct as yours. Okay, so let's see if I can make this happen now. What do we have here? We need the basic shape. I have to steal some space because this number is kind of big. The basic shape is negative sine. The amplitude. The amplitude is the absolute value of this coefficient. So the absolute value is absolute value of negative 1. If you wish, you can say that's equal to 1. And then the vertical shift is, since this is negative, this is down 6. All right? So see if I can make this happen. The vertical shift of the axis, remember, do this in reverse sequence. To shift the axis, it's down 6, so I've got to be careful with my scale. 1, 2, 3, 4, 5, negative 6. So that is now the central axis of the graph. The amplitude is 1, absolute value of negative 1. The absolute value, the amplitude is 1, so that comes up here to negative 5, and we'll go down to negative 7. So there's the peak line. There's the trough line. And now I need the horizontal axis. Well, 1, 2, 3, so that distance is 3. So that distance is 3, and a little more is pi. That distance is pi, so that distance is 2 pi. There's pi over 2. There's 3 pi over 2. Hopefully this is becoming part of your just automatic write out here. And we'll modify this with a few more things later on. But this gives us now the sides at 0 and at 2 pi. All right? So the entire graph needs to fit in that box using, we've done this first, we did this second, and now we put the 5 basic points: node, trough, node, peak, node. Play connect the dots, down, middle, up, middle, and that's fine. Okay, so now what we'll do is consider what happens if you have both a shift and a change of amplitude. So we'll see what happens with that with our next little example. Let's play f of x is equal to, let's do 2 cosine of x plus 3. 2 cosine of x plus 3. Now the key is what happens with the amplitude and what happens with the vertical shift are totally independent. One doesn't matter about the other. They're separate issues. And so, basic shape, every time, every stinking time, basic shape. The basic shape is the positive cosine graph. The positive cosine graph looks like the valley here. Amplitude. Amplitude is the absolute value. It's not just 2. Don't just write 2. Absolute value of 2. Absolute value, amplitude, absolute value. If you wish to go ahead and say 2 afterwards, that's wonderful. But it needs to have absolute value. That way I know that you know, and you know that I know that you didn't forget it, and we all know that you know that. And then we have the vertical shift. And the vertical shift is up 3. All right. So I'm going to need to be a little bit cautious with my picture here. I'm going to put my axis way down here. And as usual, go up from the bottom. The vertical axis, the vertical shift rather, is up 3. All right. So the axis of the function is no longer at 0, which is really a crooked line. It's a little bit less bad. It is up, shift up, 1, 2, 3. So this is now the central axis of the graph. The amplitude, we count up and down 2 units. So from 3, we go up to 5, and from 3, we go down to 1. So this is now the peak line up here at 5. Do we see the amplitude is 2? See, the amplitude is 2. And the trough line is at 1, amplitude is 2. And now put in the horizontal axis. Here's 3, so there's 3, so pi is a little more than that. Here's 3, there's 3, pi is a little more than that. Here's 3. Swing that around, there's 3, pi is a little more than that. If that's 1 pi, then double it, that's 2 pi. There's pi over 2, and there's 3 pi over 2. If you do this 400 or 500 times, it starts to sink in a little bit. So we have the top and the bottom. Now we need the sides. Side at 0, side at 2 pi. Now we need to, so we've done this, now we're up to here. Put the 5 basic points in. Peak, node, trough, node, peak. And play connect the dots. And if you need to, make the dots bigger. So there's one graph. If for some reason, I don't know why, but if for some reason you were asked to graph 2, this is 1 period. If you're asked to graph 2 periods, then you would just extend this picture. This is 3 pi. This is 4 pi. My picture's terrible. This is 5 pi over 2, 7 pi over 2. 1, 3, 5, 7. And then you would just repeat, you would just repeat the cycle here. So you would just repeat the cycle. If for some reason you needed 2 periods, just repeat the cycle. The only thing I will ask of you is 1 period. Now the textbook might ask for 2 periods, but all I'm going to ask is just one standard period of the graph using the vertical shift, the amplitude, and the basic shape. All right. So let's play one more, and we'll call that a video. Let's do f of x. Let's go crazy. I'm going to call it h of x. Ooh, we're going wild. That's crazy. Let's go 3 plus 1/2 sine of x. Why don't you pause the video and see if you can get that graphed out. And then when you're finished, turn the video back on and see how well I can do. All right, so let's see how well I can do this. What's the basic shape? Basic shape is the positive sine curve. What is the amplitude? The amplitude is the absolute value of 1/2. It is not 1/2, it's the absolute value. And then if you wish, you may write 1/2. That's great. And there's the vertical shift. Is it up or down? It's up. The reason it's up is not because of this plus sign. The reason it's up is because of this plus sign, which is assumed but not written. So it is up 3 units. All right? And we've seen what happens. This is going to be shifted up 3 units, but it's going to be flatter. And so essentially what happens now is once you gain some experience, you can look at this graph and start to have a feel for what the picture is going to look like. It's going to be compressed because of the change of amplitude. It's going to be compressed, but shifted up 3 units. Oh, here we go. So let's see. Here's the x-axis. I need to shift up 3 units. 1, 2, 3. This is now the axis, the central axis of the graph. We need to do the amplitude, which is 1/2. So this is 4. I'm going to say this is 3.5. That's fine. Decimals are wonderful too. This is 2.5. So the peak line is only 1/2 unit higher. The trough line is only 1/2 unit lower. So there's going to be our compressed graph. It's not drawn very well. And now we need the horizontal axis. There's 3. So there's 3 and a little more makes pi. That's pi, that's 2 pi. Pi over 2. 3 pi over 2, and there are the sidelines. All right? And so we put in the 5 basic points. We've done the shift, we've done the amplitude, now we do the 5 basic points, right? So node, peak, node, trough, node. So it's node, peak, node, trough, node, play connect the dots, and that's the basic idea. All right? If you show me this, I will be forgiving of the picture. So be sure to show me this. If nothing else, if you don't show me this, you're not getting full credit anyway. So show me this. I will be forgiving of the quality of your picture if it's reasonable. Also, one last bit on this. What I'm going to ask of you is when you draw these graphs, make them reasonable. Here's what I mean by that. I've had students in the past that when they would draw this graph, here's what they would do. I'm not kidding. This is what I would see on the exam paper. It was this tiny, microscopic, you had to get a jeweler's eyepiece to see that, an electron microscope. It's like there's 3 molecules of ink here. Don't squeeze this in so tight. If I cannot see what your picture represents, then that's not going to be good enough. That's not sufficient. No one says this is good enough. What you should do is make your picture reasonable. And here's the other way I would say it. You probably would not appreciate it if on these videos I made my picture so small that you can't see it. Well, then similarly, I don't really appreciate it when you make your picture so small that I can't see it. So don't make the picture to your standard. Make the picture to the standard of what you would expect someone to be able to interpret. So make sure your picture is large enough and full enough. It doesn't have to be gigantic, but make sure I can read and understand that you're taking this information, putting it on this graph, and making the graph of a reasonable size.